I always found optical illusions interesting, and I hope you do too, because I've made a bunch of beginner-friendly JavaScript tutorials where we inspect many of them. I really think that learning should be fun, and the same techniques we practice when coding these are needed when making more useful applications as well. So why not learn in this way? Today, we'll code the intertwining illusion. Those squares are actually placed along perfect circles, but they don't look like it, not to me at least. So get your coding editors ready and let's start peeling away the layers to get to the bottom of this illusion. Get it? Because we no, no.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
Open your code editor in an empty folder. I'm using Visual Studio Code. And here we can create a new file. Let's call it index.html. And let's start generating basic HTML code. First, setting the doc type, and then the HTML opening and closing tags. And the head section will have a title, Intertwining Illusion. And then in the body section, we create a canvas element, like so. Now let's try opening this index.html file in a browser. And this is what we get. I'm using Google Chrome. And this is the title that we set to the page. And the canvas is actually there. If we open the developer tools, we can see it in this elements section. It's just transparent. So let's give it a bit of style. I'm going to go here and set its background color to gray. And if we save and refresh, we can see it now like this. I just want to make it bigger. And for that, let me first align things a little better and set the width to 700 and the height to 700. These look good on my screen, but you can play with different ones if you want. Now, for making the drawings, we need to access this canvas somehow, and I'm going to give it an ID of my canvas. And inside of the script tag, we can now get access to the 2D drawing context of the canvas. This will have the methods we need to draw everything we want today. And what is it we want to draw? When looking at this illusion, it looks very complex, but we can divide it into components and see that one element is a circle of squares, kind of. So let's assume that we have a function called draw circle of squares and think what this function might need to have as parameters. One thing that comes to mind is the center of this circle. So I'm going to pass here the X and the Y in the middle of the canvas like this. And then a radius, maybe 300. Let's just test to see how it looks. And finally, we would also need to know how big those squares should be. Maybe we want to try different sizes and see how they look like. So that's a possible parameter as well. And now let's try to implement this function below here. So draw a circle of squares at an X and a Y with the given radius and the square size. So now I'm giving names to those parameters that are meaningful in this context here. And let's begin a path and start by drawing a simple circle first. So we are going to use the arc method at x and y, given this radius, and a full circle starts at 0 degrees and ends at 2 pi radians, or 360 degrees. So let's stroke and try our code to see if whatever we did so far works. Save and refresh, and this is what we get. Seems to be just fine. Let's try changing one of the parameters, maybe the radius, and see if it reflects what we want it to do. Maybe 50. And yeah, this is definitely a smaller circle there. Now, to draw squares along the circle, we need to be comfortable with polar coordinates. I do have a video on the topic, but maybe you can understand just when I explain it here. I'm going to remove this code and loop. Starting with a is equal to 0. I'm using a because it's short for angle. And going all the way to math pi times 2, I will increase it by a fraction of pi. Let's say pi divided by 10. And now let's get the x coordinate. So the square x is going to be equal to the given x. We have to figure out new locations according to the unit circle, and then using the cosine of a, the angle, multiplied by the radius here. So same for the square y, relative to the center of the big circle, plus the sine of a times the radius. And now to draw the circle, we can begin the path and use the rect method. Add square x and square y, and now we can pass the square size for the width and for the height. This rect method can draw rectangles, and squares are a rectangle where the width and the height are equal to the square size in this case. And now let's stroke and save, refresh, and this is what we get. Now it's important to understand what we did here. Basically, we looped through all angles from 0 to 360. If you do this, it's going to loop just through half of it. So we are getting now this kind of effect happening. I will just keep it like so. But notice one thing. This is not actually the center of the canvas here, because this top left corner of each square is the square size. So if we want it to be in the center, we need to subtract here minus half the square size and minus half the square size. I don't like it when the code goes outside like this, so let's align it in a better way. And now if we save, and I'm going to press refresh now so you see the difference. This is centered in the center screen now. Let's test this by calling draw circle of squares twice. Another call with a bigger radius, maybe 100 here. Save, refresh, and we already see some problems. The spacing between these squares changes. And that's not the case in the illusion we are trying to recreate. So we have to figure out the number of squares according to how long this circle is. I'll show you how to do that. I'm going to go here, and at the top of the function, the square count has to do with the length of the circle. And that is going to be 2 pi r, 2 pi times the radius. That's the length of the circle. And we can divide this by the square size to get a square count that will fit nicely along the circle there. And Using this, we can figure out the angle spacing and use, again, a fraction of 2 pi divided by the square count. So this angle spacing is going to go now here. And if we refresh, we get something closer to what we expect, but it's still not perfect here. They are too close to each other. So let's go here and maybe drop this 2 from here to have half the number. Let's see how it looks like. And this is much better now. But one issue I still see is that this distance between these squares is not the same as the distance between the others. And that's because we are getting here a square count that is actually a fraction. It's not a whole number. And we can fix it by putting a floor in front of it, like so. And now when you refresh, it looks like this. And the only problem I still see is happening here at the bottom, because 2 squares are being overlapping each other. And that happens for a very technical reason. Sometimes A increases here to a value that is pretty much 2 pi, but not exactly 2 pi. It's a little bit lower than that. So it's accepted here in the for loop. And this for loop will work for A is 0 and A is essentially 2 pi, but not quite. It happens because we're dealing with floating point numbers. And you could fix this by maybe making a for loop with integers instead, and going to the square count and then figuring out this A. Or a quick hack to still work with these, I add here minus the angle spacing divided by 2. Because in this way, it's not going to go near that 2 pi problem there. And if we save and refresh, we don't have that overlapping square appearing there. And now we are ready to figure out how to draw them in different colors. So what we can do here is decide on a stroke style based on what the stroke style currently is. If it's 0, 0, 0, 0, 0, 0, which means black, then we are going to use the ternary operator and change it to white. Otherwise, we change it back to black. Now, if we save and refresh, we are getting this. And it's nice, but I don't like that there are 2 black squares next to each other and 2 white squares next to each other here. We would need to have an even number of squares so that this looks better, I think. And we could do that, for example, by modifying this formula for the square count by maybe multiplying here by 0.5, giving us half the number that we have at the moment, and then multiplying everything here with 2 after we have an integer value after the floor. Multiplying it by 2 gives us an even number. Otherwise, if you don't do this with math, you will have to implement some if statements, and that's also fine, but the code is going to grow, and this is one of the benefits when you use mathematics like this. It's reducing the code, but a comment here specifying what you're trying to do will help other people out. So maybe adding a comment here is recommended. Now let's save and refresh. And you can see that this is now alternating exactly as we want. Maybe we could have a little bit more squares here. And that's also possible to do by increasing this value, for example, maybe 0.6. And let me just refresh now so you can see the difference. Yeah, I'm happy with this result. Let me know in the comments, do you use mathematics when dealing with these problems, or do you solve them using many if statements? But now let's figure out how to rotate these squares. And doing it manually, meaning that have to figure out new coordinates for each of these points, is overkill, because the canvas lets us do it in a more convenient way. We can do it by typing here ctx save translate to the square location and then rotating from that location along the given angle here. And we also have to remember to restore at the end. We need save and restore because once we translate somewhere and then rotate, the next translate that happens on the second iteration is going to be with respect to that. So we don't want those to pile up. We want to have a backup of the properties of CTX before doing these crazy things and restoring to that afterwards. And now when we translate here, there's no point to add here square x and square y. We remove them, and this is going to be equivalent code as what we had previously. This minus here is still important. Now save and refresh, and we get these. They are now following the same angle value that we are working with at each location. And we are ready to generate more of these circles of squares. So let's go back here and maybe remove one of them because we are going to write a for loop where we loop from, let's say 50, this default value, all the way to maybe 300 and increase by 50 at each step. And now this is going to go inside and we pass the radius like so. Save and refresh, and we are getting this crazy pattern here. Nice, but the illusion doesn't happen yet. We still need to do something for that. And that is to affect this angle here, basically. The individual squares should rotate not at the same angle as we're working with here, but something else. Like if I'm going to add here 0.3, for example, save and refresh, we are getting something different. And I don't know about you, but what I see here is like spirals going outward like this. And if we're going to change this to a minus 0.3, I see spirals going the other direction. Crazy. Because these angles don't align, so it somehow gives this idea that something must continue in the outer direction now. It's really crazy. Now, this value here would be nice to have it as a kind of a parameter. Maybe we call this offset. And let's have this plus the offset here. And after the square size, we can have the same behavior as before. So maybe we can try here 0.3 again as before. So again, the spiral going like this is what I see, even though we know it's not because we haven't changed the actual coordinates of each square. They are still forming perfect circles here. And to get that kind of intertwining illusion where it just looks like a mess, like somehow the circles are going within other circles, we have to change this offset depending on the iteration here. So one time we go with a positive value and the other with a negative, and the other with a positive and the other with a negative. So we can check, for example, if the radius is divisible by 100. So if the remainder is 0, then we use 0.3, otherwise minus 0.3. So it will use 0.3 for the second, fourth, and so on, and the first, third, and so on will be negative 0.3. Let's save and refresh. And now it's that crazy mess happening there. Now there are many crazy things that you can do here, really. Like you can play and study mathematics using this application that we have here. If you set the offset to 0, so we have again this where nothing crazy happens. But then maybe you play with different mathematical functions here. Like use the maybe tangent of the angle. You're gonna get this crazy thing. Or maybe the sign. Kind of looks like the Millennium Falcon. Anyway, you could play with parameters like this a lot, but it would be nice if you have a good interface for it. Maybe with sliders, drop downs, whatever. I'm curious what you can come up with, so share it with me, and the best will get a shout out in a future video. Thanks for watching and see you guys.